Matter in Motion. Section 2. What is a force? Key concept. Forces acting on an object can be combined and may cause changes in motion. You probably hear the word force used often. People say things such as, "That storm had a lot of force," or "Our football team is a force to be reckoned with." But what exactly is a force? In science, a force is a push or a pull. All forces have two properties, direction and magnitude. A newton is the unit used to describe the magnitude or size of a force. Forces acting on objects. All forces act on objects. For any push to occur, something has to receive the push. The same is true for any pull. Your fingers exert forces to pull open books or to push the keys on a computer. So, the forces act on the books and keys. A force can change the velocity of an object. This change in velocity can be a change in speed, direction, or both. In other words, forces can cause acceleration. Anytime you see a change in an object's motion, you can be sure that the change was caused by a force. Figure 1 shows an example of a force causing a change in motion. However, a force can act on an object without causing the object to move. For example, the force that you exert when you sit on a chair does not cause the chair to move. The chair does not move because the floor exerts a balancing force on the chair. Combined effect of forces. When two or more forces act on an object, the result is the combined or cumulative effect of the forces. So, the object's motion changes as if only one force acted on the object. That one force is the net force. The net force is the combination of the forces acting on an object. How do you find the net force? The answer depends on the directions of the forces. Forces in the same direction. Suppose that the music teacher asks you and a friend to move a piano. You pull on one end and your friend pushes on the other end, as Figure 2 shows. The forces that you and your friend exert on the piano act in the same direction. So, the two forces can be added to find the net force. In this case, the net force is 45 newtons. This net force is large enough to move the piano. That is, if the piano is on wheels. Notice that the lengths of the arrows in Figure 2 represent the magnitudes of the forces. The longer the arrow, the larger the force. Also notice that the combined length of the force arrows equals the length of the net force arrow. Forces in opposite directions. Look at the two dogs playing tug-of-war in Figure 3. Each dog is exerting a force on the rope, but the forces are in opposite directions. Which dog will win the tug-of-war? Because the forces are in opposite directions, the net force on the rope is found by subtracting the smaller force from the larger one. The net force is in the same direction as the larger force. In this case, the net force is 2 newtons in the direction of the dog on the right. What will happen if each dog pulls with a force of 10 newtons? The effect of the two forces will be canceled, and the net force on the rope will be 0 newtons. Balanced forces. No change in motion. When the forces on an object produce a net force of 0 newtons, the forces are balanced. Balanced forces will not cause a change in the motion of an object. Many objects that have balanced forces acting on them are not moving or are static. Often tension or compression is acting on these static objects. Tension is a force that is exerted when matter is pulled or stretched. Compression is a force that is exerted when matter is pushed or squeezed. Static objects will not start moving when balanced forces are acting on them. So, a light hanging from the ceiling does not move because the force of gravity pulling down on the light is balanced by the force of tension in the cord pulling upward. Figure 4 shows other examples of balanced forces. An object may also be moving when balanced forces are acting on it. Neither the speed nor the direction of the object will change. A car driven in a straight line at a constant speed is an example of balanced forces acting on a moving object. Unbalanced forces. Velocity changes. When the net force on an object is not 0 newtons, the forces on the object are unbalanced. When unbalanced forces are acting on an object, they cause a change in the velocity of the object. The change in velocity may be a change in speed, a change in direction, or both. Unbalanced forces will also cause a static object to start moving, or cause a moving object to slow down and stop moving. Unbalanced forces and moving objects. Unbalanced forces are needed to change the velocity of moving objects. For example, think about a soccer game, such as the one shown in Figure 5. The soccer ball is already moving when one player passes it to a second player. When the ball reaches the second player, that player exerts an unbalanced force, a kick, on the ball. After the kick, the ball moves in a new direction and at a new speed. Unbalanced forces and static objects. Unbalanced forces are needed to cause static objects to start moving. Every moving object started moving because an unbalanced force acted on it. But a moving object can keep moving without an unbalanced force acting on it. For example, when it is kicked, a soccer ball receives an unbalanced force. The ball keeps rolling after the force of the kick has ended. Unbalanced forces and direction of motion. You have learned that forces have direction. You have also learned that unbalanced forces can cause a change in the direction of motion. So, you may think that objects always move in the direction of the unbalanced force. But objects do not always move in this direction. Imagine twirling a ball on a string. The string exerts an unbalanced force on the ball. The direction of that force is toward your hand, yet the ball travels in a circle and does not move toward your hand. Figure 6 shows another object moving in a direction that differs from the direction of the unbalanced force acting on the object.